Okay, so thank you everyone for joining. So today we are going to talk about the official Visual Studio Code extension for the Yocto project. So as you can see in the title, it's written in TypeScript, and I chose this subject because to me it's a really beautiful bridge between two communities because I'm an embedded developer, and this tool is working on top of TypeScript, which is a web technology. So really the beautiful thing behind this project is that it's a mix of two technologies, the embedded world with the Yocto project and TypeScript and VS Code, which are from the web development project. So it was really nice for me to be part of this project in a team that mixes both expertise. And I think it's really nice to emphasize that the web developers are really amazing. They do a fantastic job. We use their technologies every day. So sometimes as embedded developers, we might bicker because they have this weird JavaScript typing language and tons of node modules dependencies. But I think it's nice to remember that they are amazing developers, just like the work we can do. So it's nice to acknowledge that. So we did a presentation last year on the initial release of our project. It was made possible by the Yocto project. It was part of the 5-year plan to make the tooling available and easier to use for new developers as well as experienced ones. And so my company, Savoir-Faire Linux, was selected to implement that because we are silver members of the Yocto project, and we have a lot of experience with Yocto. We did some contributions already, and we also have a lot of experience using open source web technologies. So I'm going to quickly summarize what this project is about. You may very well have already used it, I hope so. So you may know Visual Studio Code because it's probably the most popular text editor out there today. It's an IDE because it also allows you to not just edit your code, but also to run your builds and debug applications through that. So there are a lot of extensions available on the Visual Studio Code marketplace for tons of languages like C applications, Python applications. And so our goal was to provide an extension for the Yocto project. So mostly to write Bitbake recipes and also to manage the Yocto tasks for building, manipulating DevTool workspaces, and so forth. So we based our solution on what was available already. There was some people, most notably Eugene Wyans, who did an initial extension that only supported highlighting. It was really useful, but it missed a lot of features. So we implemented many more features and really provided a full IDE experience that you can use today. Of course, it's a free extension, it's official, you can download it. So on the left here, we have a few example features. We have some language features, most notably highlighting. We also provide stuff like tooltips. You have an example on the screenshot. When we hover on any variable, we can get the documentation without going on a separate web browser. We have also code suggestions. So whenever we can, we will help user by guessing what they want to type. So for instance, recipe names, classes in a required statement. We are going to provide a list of stuff that is relevant to your project and you might want to type at the time. And we also provide an IDE feature, so you can run all your Bitbake builds and DevTool management inside the UI. So in theory, you no longer need to run any kind of terminal to run your Bitbake day-to-day tasks. You can just, we have buttons everywhere to do this for you. So today, my goal will be to give you a brief introduction to how it works under the hood if you are curious. So it's written in TypeScript. This is the general architectural graph of our extension. So it's divided into two main parts in green right here. We have the language server and the client extension. So the language server can be used separately from the rest of the extension. And it's based on a standardized API that's compatible with most IDEs, like even Vim or Emacs. And you can reuse those features provided by the language server on any kind of IDE that supports this standard JavaScript API. And the other half of the extension is the client, which lives inside Visual Studio Code. So Visual Studio Code is basically an Electron web browser. So that's the back end for Firefox. It's basically a web view. It provides us with a library that we can use to display UI elements in the usual Visual Studio Code look and feel, so everything looks great. So we also interface with other Visual Studio Code libraries, mostly the Bash and Python extensions. This allows us to provide the same features for the Bash and Python sections inside Bitbake recipes as if you were typing a normal Bash or Python application inside Visual Studio Code. So you get basically the native experience even inside those small Bash and Python sections of Bitbake recipes. We, of course, as any TypeScript project, interface with a lot of Node libraries. One of the most notable ones is Node PTI, which provides the terminal experience to when we run any kind of build output. It allows us to keep the coloration and the progress bars. It's a bit more evolved than the basic JavaScript console library. Another really important part of our design is the CI, which is on the right here. I'll detail it later on. So how do we implement any kind of Visual Studio Code feature? Well, basically, it's like any common language you would use. We have a nice documentation that comes from the Visual Studio Code official one. So this is an example for registering a command. And from that, we basically read their example code and write what's appropriate. And this allows us to create UI features. Like on the right, we have the list of commands we provide for a recipe, like building one. So that's basically what the code looks like. So it's really basic code like you would expect from any language. So TypeScript is very similar to JavaScript, except it also has strong typing. So it's a bit more maybe predictable than writing JavaScript because you know what variables are. And so like any good open source code, we follow the best practices and we write some nice abstractions. So the code is very easy to read. For instance, in the middle here, we have the run bitbake terminal function, which we wrote. And it's an abstraction that covers what we need to run any kind of bitbake command from the behind our extension. So it's really easy code to read, and if you ever want to dig into it, you will be able to understand it and contribute. So I really encourage you to dig into the code. If you want to add new features, don't hesitate to dive into TypeScript. It's really nice. So that was one of the easy features, and what I wanted to discuss now was the more advanced features, and especially the ones where we encountered some challenges and had to make some optimizations or clever implementations. So one of the first challenge was how do we reach the Bitbake environment? So we need a way to run Bitbake tasks. And the most common one is to source OE init build env. So that's quite nice, but sometimes we may not really know where it is stored. Sometimes it's in ./poky, and sometimes it's in a subdirectory, or maybe the developer is using a different init script. So we created a configuration model that allows you to use a different script or a different build folder, but it doesn't stop there because, as you may know, there are many other ways to run Bitbake. For instance, we have heard about cast today. There are also people using Docker run commands with crops from Poky. Some have their own build scripts. So we came up with a general Bash command composer that is compatible with actually all of them. And the idea is basically what we have on the middle box here. You may have an optional command wrapper, which may be cas or Docker run, and then we do source, the ARM script, the build folder, and we run our custom Bitbake commands. So the example configuration for cas, for instance, is in the second box. We have the command wrapper being cas shell -c. And this actually works with most of the exotic Bitbake environments, so it's really nice. In order to help users configure this properly, we first have some nice example for all the main frameworks like cast, Docker, run, or just base source, Poiki, init, build, env. We also have added some sanity checks to help fail early and try to detect what went wrong during the configuration phase to produce nice messages. So for instance, we check if the working directory exists, if the environment script is available or not, whether Bitbake or DevTool are present inside the path. And finally, we run a Bitbake simple command. We check that the parsing is okay. And this allows us to see whether the environment is properly configured. Once we have access to the environment, we can run Bitbake builds, but we can also query the Bitbake environment to get access to more advanced language features. So this is the list of what we query. We query which layers are present, which classes, includes files, recipes, overrides, and so forth. And we need to parse basically the whole layers to get that information. Of course, we don't want to re-implement a full Bitbake parser. That will be overkill and a nightmare to maintain and keep aligned with the regular updates. So instead, we rely on the existing Bitbake utilities like Bitbake layers or Bitbake Envar to get access to the information we want. The problem with those commands is that they are slow. So they just take a few seconds. So as a Yocto developer, a few seconds is really very small, because when you run Bitbake commands, you usually are ready to wait for a few tens of seconds or maybe even hours if you don't have a cache. But from a developer's perspective, when you are using a code editor, all the features should be available in a fraction of a second. We basically expect that from any kind of web application. So the trick was to combine the relative slowness of our approach and the responsivity that is demanded by by people who are going to use the tool. So what we do actually is we run this scan just once, and we keep all the results in memory. We cache them even between sessions. If you restart Visual Studio Code, it's going to keep this information and not discard it. So a few features that rely on this, for instance, is to browse through class definitions. So whenever you have an inherit or require statement, you can actually click on any of those classes, and it's going to open the BB class file that corresponds. And to do this, we need to scan the project and see what classes are available. So even if you have some custom classes in your layer, this is going to work. Similarly, for instance, inside any variable like depends, which can refer to other packages, we suggest all the recipes that we know about inside your workspace. So these features are really intuitive to use, but it required a bit of tinkering on our end to work. We also do scanning of recipes. So this is per recipe, and it's a dedicated command. And the idea here is to run bitbake-e to get the environment, finalized environment of the recipe. And from then, we can display all the variable values. So once again, in order to be very responsive, we don't do this every time you want to access a variable value. We do it once for the file. We keep the result in memory, and it's going to be displayed instantly when you request by hovering on a variable. So the optimization here is to cache the data, but because we cached the data, we also have a responsibility to clean up our cache. So whenever a file is closed, we check if no other file pertaining that recipe is still open, and if it's okay, we discard the result. However, it's still a few seconds of parsing every time you want to refresh those caches. So maybe there are ways to do it more efficiently. If you have any way, you can. We are really looking for your feedback. Maybe we could also tweak a bit how Bitbake itself allows to connect to the tinfoil database, and maybe find a more efficient way to always have relevant data instead of relying on caching, which can become inaccurate after some time. Another feature that was a bit tricky to implement was the file discovery. So whenever we have SRC URI statements, they may often point to batches or local source files to be put inside the recipes worked here. Most of the time, those will live inside the files or $pn / directory just next to the recipe. There is no really nice tool to do this, to find out which one is being used. So we reverted to using Visual Studio Code's find TypeScript library. And initially, our implementation was really slow. So whenever you wanted to click on any of those file statements, it will take like a few seconds because we ran the find every time. So we did some optimization, and we basically used better regexes that allow to parse to list recurse into the directories only once. And it's also being done lazily, so it doesn't impact the performance of the whole IDE. It's just going to do it when needed and not preemptively. The con of this approach, which relies on a find library that's outside of Yocto, is that it's not 100% accurate. So for instance, if you have a directory for override of some files, it's probably going to point you to the basic ones instead of the overrides. So once again, if you have any ideas to make that better, we are really looking for suggestions and even contributions if you want. So regarding the file paths, we also encountered a really big issue with CAS containers. Because CAS uses Docker mount points for binding volumes in different paths. So for instance, all your layers are going to be put into /work, and your build here is going to be put inside /build. So all the file paths we get from Bitbake will be relative to within the Docker container. So we can't open those files on the Visual Studio Code on the host. They are not going to be present in the same URLs. So what we could have considered to like run Docker PS and try to find how the mount points are configured, but it will be a nightmare to implement, especially if multiple users are running the extension on a server in different workspaces. We will have no idea how to differentiate them. We could also have went for a configuration item, but that's more configuration. It's not really intuitive to use. So our approach was a bit tricky, and we basically get the inode numbers of the work and the build directory, and we compare that with what we see inside the host system. And once we have resolved that, we keep in the cache the result, and we can automatically translate any file URLs between the host and the container, which is absolutely transparent, and no one has reported any issue on our algorithm, so it seems to be doing the job really nicely. Another issue encountered by many users of Visual Studio Code when they open a full Yocto workspace is a fork bomb. So basically, when you open a Yocto workspace that contains a build directory, it's going to contain a lot of Git repositories for all the applications you might have built. So that's a lot of C applications, Python code. And it's not due to our extension, but the C, Python, and Git extension, they will try to analyze what's present inside the build directory. And this is going to create an amazing number of processes that is probably going to freeze your complete machine at some point and also consume your RAM completely. So it's outside of our scope. So what we do is provide a configuration guide to help you configure those extensions in order to skip analyzing the build directory. We have also embedded languages. So this is we presented that last year, so I'm going to be very brief on that. Basically, we want to have by embedded language, I mean, of course, the Bash and Python parts of Bitbake files. So natively, Visual Studio Code is not going to understand these are Bash or Python sections. So we need to pass those sections to the respective Bash and Python extensions. So what we do is, behind the scenes, we write some virtual files, which are excerpts from your Bitbake recipe with just the Bash or Python code. So this is what it looks like. On the left, we have the busybox.inc file, and on the right, we have the Python's virtual file we generate. So basically, we take only the Python syntax and put it inside the virtual file. We run the Python extension on the virtual file, and we report all the features inside the appropriate lines on the original Bitbake file. So that way we get all the features from the Python and Bash extensions just if we were writing a native file. like errors, which are shown in this example. We see there is an indentation error, and we see the red squiggles are being properly reported inside the Bitbake recipe as well. And the small issue with this approach is that we actually need to open the virtual file for a fraction of a second. And if your machine is a bit slow, you might even notice that. And there has been an issue pending on Visual Studio Code for years to allow running extensions on virtual files in the background, but it's still not been solved, and that's on the Visual Studio Code support team to implement. We also have a few users who wanted to know why such a package is installed inside their image, and our solution to that was to implement through our UI a way to run the task dependency explorer or task exp. It does provide the answer to this, but it's still a bit technical, so a lot of users are not really satisfied by this. Our goal for the next few releases will be to implement a shortcut to OE depends dot, which produce some much cleaner output. So you will specify your image, and it's going to report inside the UI the result of OE depends dot, which is usually just a very simple chain with how the package was installed inside the image. There's actually someone on the net who did a research on how to visualize Yocto dependencies, and that the screenshot in the middle here. It's really interesting, but it's still a bit complex, and it was part of their research project, and it's been a bit left over since then. So we think it's better to go with OE depends dot, which is the official tool, but this solution is interesting. So we were in contact with him to see how we could implement that in the future. And my last slide will be on CI. So it was really important for us to make this project maintainable. So it follows the best practices in web development continuous integration chains. So basically, it's divided into those tasks. So we first fetch the dependencies. So we actually automatically update to the latest Poki version and the latest Visual Studio Code version. And we are going to run tests automatically when a new release is released to make sure we are compatible. So we fetch the dependencies. We have some static analysis, which is going to check the style and the quality of our code. We then run unit tests. So all functions and all classes are tested independently in a mock environment. So this is really what you would get in a C++ or Python application as well. We then have a really important step, which is the integration tests. So this is when we actually run Visual Studio Code in a headless mode. It's happening inside the GitHub Action CI. And it's going to generate a Yocto project and test a lot of our features, like it's going to run a Bitbake build, it's going to integrate with the Bash and Python extensions to produce some virtual files and check that our translation between the embedded languages and the original recipe works. So it's going to retest a lot of our stuff in the actual Visual Studio Code environment. So that's really important, and it allows us to make sure most of the bugs are caught before release. And because we are lazy, we also have automated deployments. So whenever I press the release button, everything is being automatically fired up on the Visual Studio Code marketplace on Codium, which is the open source core of Visual Studio Code without the Microsoft commercial parts. And it's also being pushed to NPM. So that's for the language server part, which can be used on other IDEs like Vim. So all of this is automated, and even bumping the versions of our dependencies. It's also true for our NPM dependencies. There is also an audit job that checks for security vulnerabilities inside our NPM dependencies, so we can stay up to date more efficiently. So the challenge is with this CI, which is quite complex, and once again, it calls Bitbake, which is really slow, and we want that CI to be fast. I think it's still under 5 minutes to run, so we are really happy with that. We have a lot of dependencies, mostly Poki, Visual Studio Code. We also have like the SPDX licenses files. So in order to be really fast, we use the GitHub cache. It's a feature of GitHub Action that's extremely efficient to get stuff that we need to download but didn't change much between builds. Also, we want to run a few Bitbake builds, but those are extremely slow. We don't want to set up a shared state cache either, because it's a lot of maintenance and a lot of disk space. So we only we just in our integration test, we are clever enough to test what we want to do just by running at most an unpack task. So this doesn't require to build anything. It's really fast, and we can still check that we are compatible with Poki. So that's it for my presentation. I think we have maybe a few minutes for questions. Otherwise, you can reach out to us on GitHub issues, pull requests, and we are also present on the mailing list and IRC. So thanks for your attention. And, yeah.